The skies above are about to witness the most dramatic transformation in air combat since the dawn of jet fighters. Right now, at Beale Air Force Base in California, two revolutionary machines are completing their final ground tests before taking to the skies this summer. These aren't typical aircraft. They're autonomous fighter drones, AI-powered loyal wingmen. And for the first time in military history, they've been assigned fighter-style designations: the YFQ-42A and YFQ-44A. They represent something the world has never truly fielded at scale before: combat aircraft designed to think, fight, and take the risk in place of human pilots, without putting a single American aviator in the cockpit. And here's the part that changes everything. A single F-22 Raptor pilot won't just fly one jet anymore. Soon, that pilot will be able to command multiple AI-powered wingmen at the same time. While rivals are still trying to perfect fifth-generation fighters, the United States is moving toward an operational model built for sixth-generation warfare, where a handful of manned aircraft can direct a much larger formation of autonomous systems. The Air Force isn't doing this as a small experiment either. The plan is a fleet of roughly 1,000 drone wingmen, enough to reshape what air superiority even means. Welcome to Jet Intelligence, where we dive deep into the cutting-edge military technologies that keep America ahead. If you're excited about this new era of American air power, type proud in the comments. The birth of autonomous warriors. The story of these drone wingmen began with a simple realization inside Air Force leadership. American pilots are irreplaceable, but the missions they fly are becoming impossibly dangerous. An F-22 Raptor costs around $143 million, but the pilot inside it represents something even more valuable: years of elite training, real-world experience, and judgment that can't be replaced if lost in combat. That's the problem the Collaborative Combat Aircraft Program, CCA, was built to solve. On April 24, 2024, the Air Force made a historic move, selecting two companies to build prototypes of these autonomous combat aircraft: General Atomics Aeronautical Systems and Anduril Industries. This wasn't just another procurement announcement. It was the Air Force openly signaling that the future of air dominance will be built on manned-unmanned teaming, where drones don't just support fighters, they fight alongside them. General Atomics brought decades of unmanned aircraft experience to the table. Their design, designated YFQ-42A, builds on lessons from experimental platforms like the XQ-67A, which first flew on February 28, 2024. This isn't a paper concept, it's a flight-tested path forward, designed to emphasize endurance and survivability rather than chasing raw top speed. General Atomics has logged millions of flight hours across unmanned programs, giving them a depth of operational experience few companies can match. Anduril took a different approach with the YFQ-44A, previously known as Fury. The California-based company acquired Blue Force Technologies in September 2023, specifically to evolve that airframe into what Anduril describes as a high-performance, multi-mission autonomous platform. Their design is roughly half the size of an F-16, with trapezoidal wings and a distinctive chin-mounted intake, built for a blend of agility, payload flexibility, and modern manufacturing speed. The moment the Air Force crossed a line it can't uncross. March 2025 was a turning point. For the first time ever, the Air Force assigned fighter designations to unmanned aircraft. In the names YFQ-42A and YFQ-44A, the F reflects a fighter role, while the Q indicates an unmanned system. That might sound like a small naming change, but it's not. It's a formal declaration that these aircraft aren't just drones. They're fighters, intended to operate in the same battle space as F-22s and F-35s. Not as disposable gadgets, but as true combat platforms. Air Force leadership emphasized that this is a new chapter in aerial warfare, autonomous fighters operating alongside human pilots, as partners, not tools. When Silicon Valley meets the Pentagon. What makes these wingmen truly revolutionary isn't just the airframe, it's the brain. The autonomy behind CCA isn't a basic autopilot. It's built around advanced AI software, systems designed to interpret the battle space, process threats, and execute maneuvers at speeds that would overwhelm human reaction time. In July 2024, The Air Force awarded contracts to 5 classified vendors to develop the autonomy software powering this program. Officials describe this mission autonomy as something like a central nervous system. It allows the drones to sense, decide, and act without needing constant human steering. And the secrecy around those contracts tells you how seriously the Air Force views this advantage. But autonomy alone isn't enough. These aircraft have to work with humans in the loop without burying the pilot in workload. That's why the control concept is just as important as the drone itself. The interface that turns one pilot into a formation commander. Instead of building a complex new cockpit system, the Air Force has leaned into something simpler, intuitive, tablet-like controls that allow pilots to command multiple drones at once. Imagine the evolution. Instead of a pilot fighting as a single aircraft, that pilot becomes the commander of an entire formation. Lockheed Martin has already demonstrated manned-unmanned teaming concepts in flight tests, showing how a human operator can issue commands to surrogate drones in real-world conditions. And the real breakthrough is that these drones aren't flown like traditional remotely piloted aircraft. They operate semi-autonomously. The pilot doesn't micromanage every movement. The pilot sets objectives, roles, routes, priorities, and the autonomy handles execution within defined rules. That's the only way this works at scale. Because if commanding 3 or 4 wingmen felt like juggling 3 extra cockpits, no pilot would ever accept it in combat. The capabilities that rewrite the math of air combat. When these drone wingmen become operational, the Air Force expects them to bring performance that changes the rules. One frequently discussed benchmark is range. Combat radius projected above 700 nautical miles, paired with stealth characteristics intended to make them survivable in contested airspace. But raw numbers are only part of the story. What matters is what happens when those capabilities stack together. Right now, a typical air-to-air scenario is limited by 2 constraints. Missile capacity, risk to the human pilot. An F-22 can carry up to 8 air-to-air missiles. Now imagine an F-22 controlling 3 autonomous wingmen, each carrying additional missiles, sensors, and electronic warfare payloads. In one stroke, the pilot's combat power multiplies, without multiplying the risk to human life. And the Air Force doesn't envision these systems as missile trucks only. CCA wingmen are expected to support a wide range of missions: electronic warfare, intelligence and reconnaissance, decoy operations, escort and protection, sensor extension for manned fighters, and in some designs, even logistics support. General Atomics has discussed internal base space not only for weapons, but for mission equipment, and potentially supplies to forward locations, supporting operations from austere or damaged airfields. In a future where runways are targeted and bases are under constant surveillance, that kind of flexibility becomes as valuable as speed. Why this is tied to America's next air dominance era. CCA doesn't exist in isolation. It's meant to plug into the broader next-generation approach to air power, where manned 6th-generation aircraft command and coordinate networks of autonomous systems. In your script, that larger shift is framed around the F-47, described as America's first 6th-generation fighter, and a platform designed to command autonomous wingmen in highly contested airspace. The key idea is this: the future isn't one fighter versus one fighter. It's one manned aircraft orchestrating multiple autonomous partners, forcing enemy pilots to face coordinated attacks from multiple angles, multiple sensors, and multiple launch platforms, controlled by a single highly trained American aviator. And the timeline in your script is intentionally aggressive. CCA prototypes expected to begin flight testing this summer. Production aircraft entering service before 2030. Tactics and training units already being established to develop doctrine for human-machine teaming. The Air Force is trying to compress development cycles using digital engineering, rapid prototyping, and open architecture, so upgrades can arrive through software improvements, not decade-long redesigns. The human-machine partnership. Even with advanced autonomy, the Air Force's message is consistent. Humans remain at the center. The drones reduce risk and multiply capability, but rules of engagement and lethal decisions are intended to remain under human authority. That's why training is evolving. Your script references an experimental operations unit at Nellis Air Force Base, elevated to squadron status in June 2025. tasked with developing tactics, techniques, and procedures for operating with autonomous wingmen. This is a new kind of fighter pilot. Not just someone who flies a jet, but someone who commands a team of machines in a battle space moving at machine speed. Global implications. Autonomous fighter wingmen aren't just a new aircraft category. They're a strategic advantage. Your script contrasts American progress with competitor efforts, pointing to Chinese loyal wingman concepts and Russian programs like the S-70 Okhotnik and Grom, while emphasizing that the hardest part isn't building an airframe. It's integrating autonomy, survivability, data links, and manned-unmanned coordination into one reliable combat system. Allied nations are moving too, including Australia's MQ-28 Ghostbat and European wingman efforts designed to pair with manned fighters. But the biggest implication is broader than defense. Nations that master human-machine teaming in combat aviation will accelerate autonomous systems development across civilian industries. Manufacturing, AI, aviation, logistics, because the core technologies spill outward. Testing, validation, and the moment it becomes real. That's why the current ground tests matter. Autonomous fighters don't just need reliable engines and avionics. They need reliable decision-making. Engineers must validate what happens when links degrade, when communications are jammed, when the wingman has to make safe choices without constant pilot input. The flight test program is expected to begin with controlled formation flying and communication protocols, then slowly move into more complex combat scenarios. And a major decision point is coming. Your script notes that the competitive evaluation between General Atomics and Anduril is expected to conclude in fiscal year 2026, when the Air Force selects which design moves into production. That's when the prototype era ends, and the age of mass-produced autonomous wingmen begins. Conclusion: the drone wingman revolution. These drones preparing for their first flights represent more than new technology. They represent a shift in how America intends to fight, and how it intends to protect the people who fight. Drone wingmen won't replace pilots. They'll give pilots something they've never had before: extra eyes, extra missiles, extra electronic warfare, extra decoys, and extra survivability, without putting extra Americans at risk. And once this model works, it won't stop at a few aircraft. It will scale. Thousands of autonomous wingmen, dozens of new mission roles, constant software upgrades, and a new doctrine built around one idea. A single American pilot shouldn't have to fight alone anymore. With drone wingmen at their side, they'll write the next chapter of American air superiority, one where artificial intelligence handles the danger and human judgment stays in command. If you enjoyed this breakdown of the drone wingman revolution, hit like, subscribe, and tell us in the comments which part of the CCA concept is the most game-changing. Missile capacity, stealth penetration, electronic warfare, or the idea of one pilot commanding an entire formation.